Measurement is nothing but the comparison of any physical quantity with its standard unit is called measurement, right? The comparison of any standard physical quantity, any physical quantity with its standard unit is called measurement. Physical quantity next. All quantities which can be measured directly or indirectly in terms of loss of in terms of which the laws of physics are described are called physical quantities, fundamental quantities. Those physical quantities which are independent to teach each other are called fundamental physical quantity. Means these are basic quantities, fundamental quantities, supplementary physical quantities. Supplementary physical quantities are radian and steradian are two supplementary fundamental units, derived quantities. Those physical quantities which are derived from fundamental quantities are called derived physical quantity. Means which can be derived like a density. If you take density equal to mass per unit volume, mass per unit volume. So here you can observe density is derived from mass and volume, right? That's why it is derived physical quantities. Next, scalar. Those physical quantities which require only magnitude but no direction for their complete representation are called scalars. Scalar example, we can take speed you can consider, and distance and mass. So these are the scalar physical quantities. So these have only magnitude. These quantities have only magnitude. Okay. So speed we can take 5 meter per second. Distance if you consider 6 meter. Mass if you consider 6 kg. So you can observe all this have only magnitude. Next, tensors. Tensors are those physical quantities which have different values in different directions at same point. So at same point, different values in different directions. In different directions. Right? Yes. Next, vectors. Those physical quantities which require magnitude as well as direction for their complete representation and follows vector law are called vectors. So which have both magnitude and direction. So suppose if I take velocity if you consider it has both magnitude and direction. Even acceleration also if you take it has both magnitude and direction. Next, polar vectors. Polar vectors if you take the vectors, here you can see these vectors have a starting point or a point of application such as displacement, force, etc, right? Those are called polar vectors. So axial vectors, so these vectors represent rotational effect and act along axis of rotation in accordance with the right hand screw laws such as angular velocity, torque and angular momentum. Next, equal vectors. Two vectors of equal magnitude and having same direction are called equal vectors. So here it has two vectors equal magnitude. So I am taking this have equal magnitude and same direction. So I am taking like this, right? Yes. So I'm considering this have A bar magnitude and B bar magnitude. So this is a vector A and vector B. So both have same magnitude. So means equal magnitude and same direction. Direction also same. So in one direction only it is showing, right? Yes. Those are called equal vectors. Next, negative vectors. Negative vectors are nothing but two vectors of equal magnitude but having opposite direction. So now I am taking, so suppose example I am considering, so this is one vector A bar, another vector B bar. So this one vector, this is another vector B bar. Both have equal magnitude. So you can observe here equal magnitude. Magnitude means 5 and here 5. So 5, if you take these two or force vectors, so I am taking 5 Newton, 5 Newton. Equal magnitude but opposite in direction. One you take positive, another one will be taking minus. So those are called negative vectors. Negative vectors. Next, zero vector or null vector. So zero vector or null vector means a vector whose magnitude is 0 known as zero vector or null vector. So use magnitude is 0, right? If A equal to 0 then magnitude is 0 and B equal to 0 and so K equal to 0 like that. So we can take the different vectors. So all the vectors, so if you take each vector magnitude is 0 then we can say that is zero vector or null vector. Next, unit vector. So unit vector is nothing but normally if you consider, so what is vector having unit magnitude is called unit vector. Suppose I am taking A bar vector, right? So this is a bar vector, so whose magnitude is 1 unit. So use magnitude is 1 unit. So we can also take a cap equal to A bar by mod A bar. So we have to find out the magnitude. Suppose I am considering A bar equal to I cap plus J cap plus K cap. So if I take this vector, so his magnitude must be equal to 1, I said, right? Yes, vector magnitude must be 1. So we can take, if it is unit vectors, to find out unit vector of this one we need to take A bar as it is I cap plus J cap plus K cap, and so root over magnitude. If you want to find out, if you are taking magnitude, root over 1. So magnitude, so if you have to take this value, that is 1 square plus 1 square plus 1 square, then you will get root over 1 plus 1 plus 1 is 3. So root over 3. So you have to write here. Then this is the unit vector of A bar vector. Right. Now co-initial vectors. So co-initial vector means vector having a same common initial point are called co-initial vectors. So these are the initial point of all the vectors. So I am taking A bar, B bar and C bar, and D bar also I am taking. So these are the all the vectors. All, so I am considering here 4 vector. Or 4 vector initial point is at one point. There is a common point, right? So vectors having common initial point are called co-initial vectors. Next, collinear vectors. Collinear vectors means vector having equal or unequal magnitude but acting in the same or parallel lines are called collinear vectors. So if it is acting in the same direction or in a same manner like that, then we can say collinear vectors. So next, coplanar vectors. Coplanar vector means vectors acting in the same plane. Vectors are acting in the same plane. So if I take, so here this is x-axis, so this is y-axis, and I am taking this is z-axis. So this is one plane, and I am taking this one plane, and this is the another plane. So like that, if you take, if vectors are acting in the same plane irrespective of magnitude, then we can say that those vectors are called coplanar vectors. Localized vectors. Localized vector, if you take, so localized vector means a vector whose initial point is fixed is called localized vector. So whose initial point is fixed, that's why we can say localized vector, right? Yes. So we can also go to the next one, non-localized vector. So we can see non-localized vector. Here we can observe free vector, non-localized vector or free vector. Non-localized vector or free vector, if you consider a vector whose initial point is not fixed, a vector whose initial point is not fixed, those are called free vector or non-localized vector. So here we can observe non-localized vector or free vector. Next, position vector, a vector which gives position of an object with reference to the origin of coordinate system is called position vector. Next, we can go to the displacement vector. Displacement vector, the vector which tells how much and in which the direction of an object has changed its position in a given interval of time is called displacement vector. A scalar product or dot product of vectors. Scalar product or dot product of two vectors. The scalar product of two vectors is equal to the product of their magnitudes and cosine of the smaller angle between them. Vector product or cross product of two vectors. Vector product or cross product of two vectors. The vector product of two vectors is equal to the product of their magnitudes and sine of smaller angle between them. Motion. Next, if an object changes its position with respect to its surroundings with time, then it is called in motion. Next one, rest. If an object does not changes its position with respect to its surroundings with time, then it is called at rest. Next one, distance. The length of the actual path covered by an object is called the distance. Displacement, the shortest path between the initial and final position of an object during motion. So here I am taking this one and this another, so A and B. So if I consider from here to here and here to here, I am taking, okay. So if I move from A to B and B to C, I am considering the shortest path from initial point to final point, that is called displacement. The shortest path from initial point to final point is called displacement. Speed, the time rate of change of position of the object in any direction is called speed of the object. Uniform speed. Uniform speed means if an object covers equal distances in equal interval of time, then its speed is called uniform speed. Non-uniform speed or variable speed. Non-uniform speed or variable speed, if an object covers equal distances in equal interval of time and vice versa, then its speed is called non-uniform or variable speed. average speed. The ratio of the total distance traveled by by the object to the total time taken is called average speed of the object. Instantaneous speed. When an object is traveling with variable speed, then its speed at a given instant of time is called instantaneous speed. Means at particular instant, if I take at particular instant, what is the speed of the object, then that is called instantaneous speed. Next one, velocity. The time rate of change of displacement of an object in a particular direction is called its velocity. Uniform velocity. If an object undergoes equal displacement in equal interval of time, then it is said to be moving with uniform velocity. Non-uniform velocity. So, if an object undergoes unequal displacement in equal interval of time, then it is said to be moving with a non-uniform or variable velocity. Average velocity. The ratio of total displacement to the total time taken is called average velocity. So, a velocity, right? So velocity average I am taking, total distance, total displacement, t total displacement by total time taken, total time, total time. So instantaneous velocity, the velocity of any of particle at any instant of time is known as instantaneous velocity. So next, relative velocity. Relative velocity of one object with respect to another object, so is the time rate of change of relative position of one object with respect to another object. So if one object is moving, suppose I am taking A and suppose I am taking B. So if I take A with respect to B, so we are comparing. So velocity of A with respect to velocity of B. So with respect to, if you mention, then it is taking, so relative velocity. Next one, acceleration. The rate of change of velocity with time is called acceleration. So acceleration, if you take v minus u by t. So v is nothing but final velocity, final. So u is nothing but initial velocity, initial. And if you take t is the time. Okay, time I am considering. Next, uniform acceleration. Uniform acceleration is nothing but if an object is moving with uniform acceleration, it means that the change in velocity is equal for equal interval of time. So if an object is moving with uniform acceleration, it means that the change in velocity is equal for equal interval of time, right? Yes. So non-uniform acceleration, non-uniform acceleration. So, if an object is moving with a non-uniform acceleration, it means that change in velocity is unequal for equal interval of time. Instantaneous acceleration. So, instantaneous acceleration means it is defined as acceleration of the object at any instant of time. So, if a particular instant, if you take A, if you take B, if you take C, if you take D, so three are moving at particular instant, what is the speed of the or acceleration of the body B, that is called instantaneous acceleration. Even for A and D and C also will be considered. Next, uniform motion. If an object is moving along the straight line, covers equal distance in equal interval of time, it is said to be uniform motion along the straight line. Uniform motion means along the straight line we can consider. Non-uniform accelerated motion. So non-uniform accelerated motion means when acceleration of particle is not constant, then motion is called non-uniform accelerated motion. So motion in a plane. Motion in a plane is called as motion in two dimensions. Example, projectile motion, circular motion. These all we can consider motion in a plane. Position vector, a vector that extends from a reference point to the point at which particle is located is called position vector. So position vector means I am taking here, so I am considering this x-axis and y-axis. So vector will be represented with respect to coordinate axis. Somewhere it is position extends from a reference point to the point at which particle is located is called position vector. So displacement vector. So the displacement vector is a vector which gives the position of a point with respect to the point other than the origin of the coordinate system. Velocity vector. Velocity of an object in motion is defined as the ratio of displacement and corresponding time interval. So that is called velocity vector. Average velocity. So it is defined as the ratio of displacement and the corresponding time interval. So average velocity is nothing but normally is velocity of we are considering displacement by time taken. So same thing here also we'll consider. Next, instantaneous velocity. As we discussed in the previous cases, velocity of an object at any instant of time is called instantaneous velocity. Next, acceleration vector. It is defined as the rate of change of velocity. So acceleration is nothing but rate of change of velocity. So average acceleration, it is defined as the change in velocity divided by the corresponding time interval is called average acceleration. So what is average acceleration? So change in interval of time divided by corresponding time interval. Next, instantaneous acceleration. What is instantaneous acceleration? It is defined as the limiting value of the average acceleration as the time interval approaches to 0. A time of flight, it is defined as the maximum vertical height covered by a projectile. So maximum height, so if you take a coordinate axis, so this is x, I am taking, this is y. If you throw the particle from here to here, so it reaches to the maximum distance by reaching the maximum height. So I am taking this the maximum height, and this distance, how much distance is covered by the body, right? That is a distance. And horizontal range, it is defined as the maximum distance covered in horizontal distance. So circular motion is the movement of an object in circular path. So if it is moving in a circular path, then we can say circular motion. Uniform circular motion, if the magnitude of the velocity of the particle in circular motion remains constant, then it is called uniform circular motion. Non-uniform circular motion. So non-uniform circular motion means if the magnitude of velocity of the body in circular motion is not constant, then it is said to be non-uniform circular motion. So non-uniform circular motion, magnitude is not constant. Angular displacement, angular displacement is the angle subtended by the position vector at the center of the circular path. That is angular velocity. The time rate of change of angular displacement is called angular velocity. Angular acceleration, the rate of change of angular velocity is called angular acceleration. Centripetal acceleration, in a circular motion, then acceleration acts on the body whose direction is always towards the center of the path. This acceleration is called centripetal acceleration. So if you take like this, so if it is acceleration towards if towards the center, towards its center. If I am taking towards its center, then it is called centripetal acceleration. So centripetal force. So is that force which comes into play when the body moves in a circular path. It is directed along the radius of the circle of its center. Centrifugal force. It is defined as a radially directed outward force acting on the body in a circular motion as observed the person moving with the body. Next one, inertia. The property of an object by virtue of which it cannot change its state of rest or uniform motion along a straight line or its own. Normally if you take, so the body is at rest, the book is at rest, so like that if you take, so the fan is moving continuously, bus is traveling. So all these examples you can see, unless until we apply force, the object does not move or does not change its position or a place or rest or direction. So that is inertia. So inertia of rest. In this case, especially inertia of rest, it is defined as the tendency of a body to remain its position of rest. A body at rest remains at rest, cannot start moving on its own. Inertia of motion. Inertia of motion means it is defined as the tendency of a body to remain its state of uniform motion as it is moving in a straight line. So a body in uniform motion can neither gets accelerated nor gets retarded on its own. Also it cannot stop by its own. So if it is moving condition, it does not stop its own, it does not move its own until external force acts on it. Inertia of direction. It is defined as inability of a body to change by itself its direction of motion. So as we discussed, the body does not move by its own. So if I'm taking it in a particular direction, I'm taking this is a north, this is south, and this is east, this is west. So if the body is moving towards the east directions until unless we apply force on it, so the body does not change its direction. Change, it does not change by itself. So next one, force. A force is a push or pull which changes or try to change the state of rest or state of uniform motion or size of the body. So if you so force can change the shape of the body, force can change the size of the body. Yes, so that is push or